we'll pick up where we left off. So you all know, and we talked about this extensively, that you can take a line, you can write an equation that describes a line in space, two-dimensional line. Now, if you are, I don't know if it's fortunate or unfortunate enough to take Calc 2 in college, if you're doing any engineering field, if you're doing any kind of physics, any kind of math, any kind of computer stuff, you're going to take Calc 2. And in Calc 2, you start to take a line like that and you rotate it until it forms a three-dimensional object. And you can make, you could have a curve like that, you rotate it, you get a bowl. It's really cool stuff, actually. And you can design objects like that. But aside from that, we can take these three-dimensional graphic things using Schrodinger's equations, and these are these areas of high probability. So these are the orbitals. And the one thing that we save from the earlier model, from Bohr's level, what was the big deal about Bohr's model? What was the big idea from Bohr's model? What was the groundbreaking thing? Energy levels, exactly. And in the Bohr model, we kind of imagine them like floors on a building, very straightforward, that there's the first energy level and the second energy level and the third energy level, and they're just like floors, these discrete places. But Schrodinger makes them more complicated, which of course everything gets more complicated. Nothing ever gets simpler. So now is when we start to talk about the orbitals. Okay. So we have all these orbitals, we have all these electrons on any given atom. And I'm going to give you a metaphor. Next year or 2 years down the road, many of you are going to go off to college. And somebody will probably send you a card at some point. You'll get a birthday card or, a Halloween card or a, hey, gee, we're missing you here at home, what are you doing card or something. Somebody will want to mail you something. To get that to you, they're going to have to address it. Duh. And that address is going to have to include multiple things. So I'll pick an example of a university based only on that I know a few names, because I had a friend who went there. OU, Ohio University in Athens. One of my friends in high school went there. So if I wanted to get a card to her, I would have to include the residence hall she was in. She was in Chubb Hall. Why I remember it, because it was really stupid. So, Chubb Hall. Okay. Well, that's not going to get it to her. Second floor. We're getting more specific. Chubb Hall, second floor, room 8. Okay. Well, there's an A desk and a B desk in there. When they drop off mail, it needs to either go to A or B. Each room was 2 people. So, Chubb Hall, second floor, room 8, desk A. That'll get a card on her desk. That's all these quantum numbers are, is an address system. It's a way of describing each individual electron very specifically. That said, now these are called quantum numbers, and I will quote for you what the Ohio Academic Content Standards have to say about quantum numbers. Detailed discussion of quantum numbers is beyond the scope of a high school chemistry class. So we're not going to do a detailed discussion of quantum numbers. We're going to do a fairly superficial discussion of quantum numbers. But even without talking about the numbers very specifically, we still have to know what they mean. We have to know what they're telling us. So the broadest, the biggest, like saying Chubb Hall, the sort of most general piece of information about an electron's address is this first thing, this principal quantum number. It's called N. It is the only one of the quantum numbers that I will ever really expect you to remember the name for, but I will expect you to remember that. The principal quantum number is the big one that tells you what main energy level it's on. Okay? And they have actual numeric values. All of these do. When we get into the other ones, the numeric values are really bizarre. We don't talk about them. I probably couldn't identify most of them if you threatened me with a pointed electron. Couldn't do it. Don't care. Don't need to know. For the principal quantum numbers, however, these are easy. It's just like 1, 2, 3, 4. You get the picture. I think you can remember those. So those are just the main energy level. Then we get into angular momentum, or magnetic quantum, and spin quantum numbers. These, I don't expect you to remember names for or anything else, but we're going to learn some sort of alternative names that describe what they are. That's what you're going to work with for the most part. So, on this chart, we're going to look at what those numbers describe. Okay, and there are 4 numbers we're working with. So every single electron in the entire world has got 4 things that will identify exactly where it is, and you're going to use them. So the main energy level, the first one, easy peasy, 1, 2, 3, 4. These go up. There's a 5, a 6, a 7. We don't ever talk about, we talk a little bit about the 5th and the 6th. The 7th is so far beyond our scope that, you know, we'd get like altitude sickness if we talked about it. It's just not something we're going to do. And so these are pretty easy. These are really basically Bohr's levels. This is Bohr's first level, second level, third level, fourth level. Never mind the fact that he hadn't figured it out for anything beyond hydrogen. This is what he was talking about. Well, that's great, but we don't just have levels, we have orbitals. So, we start off with the next level of identification as being the subshell. So we can tell you what main level you're on. We can tell you what subshell you're in. And the easiest way to think about subshell is shape. Because each subshell has a different shape. And on the first main energy level, we only have one shape. And that shape, well, I'd like you all to visualize a beach ball. Holding it in your hands. You got your nice little beach ball. That's it. It's spherical. And because particle physicists are very creative, you know what they call it? An s orbital. And that's the only thing that exists on the first main energy level. One single s orbital. It's all that's there. It's pretty empty down there. Now, notice that this little line over here says energy and it's going upward. Every time we go up a level, we gain energy. So the second energy level has more energy than the first. The third has more than the second. The fourth has more than the third. You get that. I didn't have to explain that to you, but I did. Well, as we go up a level, if the level below you has it, you have it. So the second main energy level, does it have an s orbital? You betcha. And this is the 1s, this is the 2s. Well, that doesn't, we'll skip that for right now. We just know it's got an s orbital. It's got an s orbital. It has another shape of orbital too. And there is no good way to describe this. Dumbbell, double drumstick. You can call it anything you want. So this is an S. This, I usually draw it as a little 8, is a p orbital. That's what a p orbital looks like. We'll pass that around. So there are 2, and I should probably make that clear that it's not there. We'll draw it on its side so it doesn't look like it is the number 8. So there are 2 shapes on the second main energy level. S shape and P shape. Okay, so if we go up to the third main energy level, do we have an S? Yep. You think we have a P? Yep. We get one new shape. This one is just bizarre. I call it the double dumbbell. I mean, they get much weirder. But it's a double dumbbell, and it's called, oh, this is our P, it's called a d orbital. So on the third main energy level, we have 3 shapes. First main energy level has 1 shape, second main energy level has 2 shapes, third main energy level has 3 shapes. If somebody threatened you with a p orbital, held you at p orbital point and said, how many shapes do you think there are on the fourth main energy level? What would you say? So on the fourth main energy level, we have our S, we have our P, we have our D, and we have our F. I'm not drawing it. Do you notice that? I'm going to show you why in just a second. So now, we've got this, and we're only talking about up to 4 right now. When we start to actually put electrons in orbitals, we'll talk about all the way up to 7. But right now, we don't need to go any higher than this. So the next quantum number gets at how the thing is arranged. So I want you all to visualize that beach ball I asked you to hold on to. You've got a beach ball in front of you. You're holding it. Turn that beach ball 90 degrees. Does it look different? Turn it another 90 this way. Does it look different? Turn it another 90 this way. So basically, you can spin this whole thing all over the place. Is this beach ball ever going to look different to you? No. How many ways are there to orient a beach ball shaped object around the origin of a graph? Just one. Doesn't matter how you turn it, it's going to look the same. So this orientation quantum number, this is if you can turn the object and it looks different, we call that its orientation. So as many ways to orient something as we have to have that many of the thing. Uh-oh, somebody stole my s orbital. So as many ways to orient something as we will have that many of the orbital. So guess how many s orbitals we have on the first main energy level? Just one. Because there's only one way to orient it. So we have one s orbital. Okay. Seems pretty straightforward so far. Well, on the second main energy level, we have a slightly larger S. It's a little bit bigger than our first beach ball. How many ways are there to orient this thing? One. So guess how many s orbitals we have on the second main level? One. But on the second main level, we added a P. So we have our P here. And we can orient it. Well, I'd like you all to stand up, actually. We can arrange a p orbital 3 different ways. Guess how many p orbitals we have? 3! So we have, I've drawn this badly, the x, the y, and the z is notoriously difficult to draw. You'll just have to pretend that that's the z-axis. And we call this orbital the 1s orbital. We call this orbital the 2s orbital. When we name those p orbitals, we have to specify what direction they're pointing in. So we have the 2px, we have the 2py, and we have the 2pz. And we'll spend much, much more time with these. You'll be very familiar with them by the time we're all done. And that tells us which orbital we're talking about, which p orbital. Okay, so we're on the second level. Great. Oh, we're in a p orbital. Great. Which one? Okay, she's in Chubb Hall. Fantastic. She's on the second floor. Good. Which room? So if we go up to the third main energy level, we know we have 3 shapes now, right? So we have an S, and this would be called the what? 3s. Yeah. This is the 3s. We have all those p orbitals, and I will draw them very tiny for lack of space. Well, we have, so we'll just block those off as the p's. Then we have the d's. How many ways do you think there is to arrange this? I mean, infinite on one level, but we come up with 5. Let me show you. Okay, so we've got our 3D orbitals, 5 orientations. So, fourth main energy level. We have an S, right? What's it called? 4s. We have our 4 p's, 4px, 4py, 4pz. We have 4d1, 4d2, 4d3, all that. The 4d1, 4d2, 4d3, 4d4, 4d5. And now we add that stinking f orbital. I'm not going to draw it because I can't. Does anybody see any patterns so far? I'll pause. Because we had 1, 3, 5, now we have 7. There's actually an orbital above F. It's called a G orbital. Guess how many orientations there are? 9. Right. So we have 7 F orbitals. We're not going to name them. We're probably not going to fill them out. But you should know that they exist. So now we're going to start talking about the most specific piece of information. That'll be great on YouTube. The most specific piece of information we can have about an electron. The thing that gets this birthday card right onto its desk in the dorm room. That's its spin number. Now, when we talk about spin number, every electron has a spin number, and there are only 2 possibilities. There's up and there's down. That's it. And up is traditionally shown by a little half arrow like that, and down is a little half arrow like that. So they're a nice little complementary pair. One's up, one's down. So we can say, oh, you're an electron on the 3rd main energy level in the 3px orbital, and you have an up spin. Now, this is not literally things spinning. This is a particle physics expression. Nothing is actually doing this. Okay? There's no little wheel rotating. There's no hamster wheel. There's no nothing like that. It's an expression. If you want to know more about the reality of electron spin, I can give you the email for a nice particle physicist, and you can ask him your questions. Not me. We assign spin for each electron. So now you've got a blank page in your notes. If you've got the notes from me, we're going to start drawing in actual electrons. Okay. On the 1st main energy level, what shape of orbital do we have? You can look back in your notes. What shape of orbital do we have? S. Yeah, a little ball. So we have the 1s orbital. Here, I'll do that. And it can hold 2 electrons. I'm just going to tell you that. So 1 electron is up, 1 electron is down. Easy enough. On the 2nd main energy level, what do we have? What's the first orbital that we have on the 2nd main energy level? (2s). We have a 2s orbital. And guess how many electrons it can hold? Well, I'll just tell you. 2. And 1 is up, and 1 is down. Then we have our 2p subshell. And in that 2p subshell, we have 2px, 2py, notoriously difficult to draw, the 2pz. Okay. So 2px can hold, are you sensing a pattern here? Can hold 2 electrons. 1 is up, 1 is down. 2py can hold, if you had to guess, 2 electrons. 1 is up, 1 is down. 2pz, I know, you'd be going out on a limb. 2 electrons. 1 up, 1 down. 2nd energy level is full. second main energy level is full. We will not probably get above the third today together. But what's the first orbital we'd have on the third main energy level? We have a 3s. It's a beach ball, and it's a little bit bigger than the last two beach balls. And it's got 2 electrons! One up, one down. Now, on that same third main energy level, what's the next shape we can have? We can have P's, yeah. We've got the 3p subshell, we've got p-shaped orbitals, and we're going to have the 3px, the 3py, and the 3pz. And guess how many electrons they have? 2. 1, 2, 1, 2, 1, 2. Sensing a pattern? So weird. They do. So now we have d orbitals. So we've got, and these are really crazy to draw. We have 3d1. We have, let's see, how do I even draw this? Nope, that's not it. I'm trying to look at them from here. We'll do the laying back one first. 3d2. And then we've got the standing up one. Then we've got the completely on its back one. Then we have the dumbbell with the donut around it. Crazy. Crazy. So guess how many electrons 3d1 can hold? 2! Good pattern recognition. Guess how many electrons 3d2 can hold? 2! Guess how many electrons? 2. Very, very Deutsch. Up, down. 3d4, 1 up, 1 down. 3d5, 1 up, 1 down. And it just goes on like this. So we can assign a very specific location to any electron in any atom. And everything about how atoms behave, everything about how matter behaves, is all based on this stuff. Just crazy. It's just crazy. We're actually going to stop here. So